Hey, all, today we're going to switch over from talking about expressions and we are now going to talk about equations. And the thing that turns an expression into an equation is an equal sign. So these will have equal signs, and the things that we are able to do with equations are solve them. So we have been evaluating, simplifying, translating expressions, and once we move into equations, we will start solving them. So we're going to find out what a variable is equal to. These are called multi-step equations because they will take more than one step, more than two steps usually. And so I solve equations maybe a little bit different than you're used to seeing. And if you have a way that you like to solve equations and that works for you every time, then I encourage you to use that way. It's okay. There are different ways to do things, but I'm going to show you one way that I know how. When we have multi-step equations, a lot of times we have terms that have variables. So we have terms with variables here. We have this 5x, it's positive. We have 3x, it's also positive since there's no sign. And then we have constant terms, positive 6 and negative 6. And what I like to do is I like to get all of the variable terms to the other side of to one side of the equation and all the constant terms to the other side. And I typically put the variable terms on the left. You can put them on the right if you want to. Both of them are absolutely fine. So whenever I move a term to the other side of the equal sign, you need to switch the sign that is in front of that term. So actually what we're going to say is you need to switch the operation. So plus is addition, minus is subtraction. If there is no plus or minus, we assume it's a plus. So when you switch sides of the equal sign, you're going to switch operations. And again, if you have a method, there's a classic method that people use and it's very successful. If that's what you want to use and you're good at it, please do that. If you didn't like that method, hopefully you like this one. So I'm going to move my 3x over here. I'm going to switch which side it's on. And so that means I'm going to switch its operation. There's no sign in front of it. So that means that there's a plus there. And so when I move it over here, I'm going to turn it into a minus. So I still have my 6, my plus 5x, and now I have a minus 3x. I'll keep my equal sign, and then I haven't done anything with that minus 6 there. Now I want to move this constant, this positive 6. There's a plus in front of it, even though we didn't write it. I want to move it over here with my other constant. And when I switch the side of the equal sign, I'm going to switch the operation we're doing. And so on this left side, we're left with 5x minus 3x. We have our minus 6 that was over here. And this plus 6 turns into another minus 6 when it comes over here. And so now what we can do is like when we had expressions, we can combine like terms because we have like terms on the left and we have like terms on the right. So 5x minus 3x is 2x. Oops, I said 2 and I wrote 3. It is 2. And minus 6 is minus 12. If you have a hard time with that, it's no problem using Desmos. And now we need to do one more thing to solve this equation. This 2 is multiplying the x. There's multiplication there. So we want to move this 2 over here. Right now, the 2 is multiplying something. When we switch sides of the equal sign, we're going to switch the operation it's doing. So over here, it's multiplying the x. When we move it over, it's going to be dividing the 12. And so now we can actually do negative 12 divided by 2 and get negative 6. And now we have solved the equation. Again, I really want to reiterate that if you have a different method, one that you learned in previous classes that you use and it works for you, please do use that method. This is just a different way of thinking about it. So let me do another one. And I'm going to do this one with slightly less explanation, but I'll show you my steps. I have two variable terms on the right and no constant terms. So I'm going to change it up a little bit here, and I'm going to move my variable term over there to be with the other ones. So I'm going to leave the 8 where it is. I'm going to leave the minus x. I'm going to leave the plus 7x. And this plus 4x, when I switch sides, I'm going to switch its operation. It's going to become minus 4x. 8's going to stay. Now I can combine my like terms because all of these terms have variables. I'm going to combine -1 with positive 7 and -4, and I'm going to get positive 2x. Again, you may use Desmos if you need it. Don't be shy using Desmos to help you. And my last step is I got to move this 2. It's multiplying the x right now. So when I move it to the other side, it's going to divide the 8. And I'm going to get x to be 4. So what I want you to do here is I want you to pause the lesson and I want you to try this one on your own. And then when you press play, my solution will show up. I really want you to pause here and try this on your own. It's okay to get it wrong. The important part is giving it a shot and then seeing where your mistakes are. So hopefully you got x equals 8. If you didn't, look at what I did and see if maybe you forgot to change a operation, or maybe you just combined like terms incorrectly. That's okay. If you can find your mistake, that's good. If you can't find your mistake, please do ask for help and I will help you find that mistake. There are 2 special solutions that we could end up with when we're solving an equation that don't look like something like we just had, x equals 8 or x equals 4 or x equals -6. There are a couple special cases that we could arrive at. So I'm going to pause here and I'm going to solve this equation, and I'm going to show you what happens at the end. So I solved this equation by first moving this minus b over here and making it a positive b or plus b, change the operation. Then I moved my +1 to the right and it turned into -1, change the operation, switch the operation. And when I combine like terms on both sides end up being 0. So I have this thing where I don't have a variable left anymore, but both sides are the same number. And so what that means is any number I plug in for the letter b is going to make my equation true. So let me point out that when we solve for a variable, so when we solve for x in this one, what the solution means is that if I plug 8 back in for x on both sides where I see x, if we evaluate both sides like we did at the beginning of the year, then this equation will become true. That means the left side of my equation will be equal to the right side of my equation. That's what a solution means. It's a number that makes both sides of the equations equal. When I solve an equation like this and I end up with an answer like this, that means any number I plug in for b will make both sides of my equation equal. And so that means our solutions, we say, are all real numbers. Any number that's considered a real number, which we can talk about, can be a solution for b. The other way that we say it is that this equation has infinite solutions. Those are 2 ways we'll write our solution when we have this case where we end up at the end where both sides are equal, but we can't really solve anymore. The other special case is when we don't have any solutions. That means there's no number I can plug in for x for both sides of this equation that will make both sides equal to each other. So I'm going to pause here and I'm going to write the solution down, and then I'll show you what it means to be no solution. So here we end up at the end where we have one thing on each side, and those 2 things are not equal to each other. And so we can say not equals to by putting a little line through the equal sign. 5 is not equal to 0. And so what that means about this equation that we started with is that it has no solutions. There is no number that we could plug in for x in all three of these places that would make both sides of the equation equal. And so then we would say there are no solutions to this equation. So there are three types of answers you can get when solving the equation. You can get an answer where you actually end up like this, where we have our variable, whatever it is, x or b, and it ends up equal to a number. Or we can end up with one like this, where we have two sides of the equation at the end where we can't solve anymore are equal to each other. That is all real numbers or infinite solutions. And then finally, we have one where we end up with two things that are not equal to each other. And so that means there's really no solution to this equation. And so we would say there is no solution. If you ever want to check your answer, if I wanted to check to make sure that x is actually equal to 8, I could evaluate both sides of the equal sign and make sure they come to the same answer. So I could plug 8 in like we did at the beginning of the year on my left side, and I could plug 8 in on my right side, and I can evaluate both sides like we evaluated expressions. So 4 times 8 is 32, plus negative 11 is 21. And 3 times 8 is 24, plus negative 3 is 21. And so since both of the sides equal the same thing when we plug in 8 for x, that means that 8 is our correct solution. It's made both sides of the equation equal. So I've got 5 practice for you today. Make sure you do all 5 practice. If you need some help before you start, please do ask. If you need help or get stuck at all while you're trying these, as always, please ask. Take your time on them, and good luck.